Have you ever been stumped by a trig problem just because it wasn't in that nice, simple first quadrant? Well, today, we're going to unlock a really powerful tool that makes solving for any angle, and I mean any angle, a total breeze. It's called the ASTC Rule. Let's get right into it. You know, it's pretty easy to get comfortable in that first quadrant, right? Everything's positive, life is good. But then what happens when you get an angle like 210 degrees? Do you have to scramble for a calculator just to figure out if it's positive or negative? No way. Stick with me for a few minutes and you'll be able to answer that question in a split second. So, the real problem here is what happens when we go beyond that first quadrant. I mean, from 0 to 90 degrees, it's all smooth sailing. But trig works on a full 360-degree circle. And to really master it, we absolutely need a strategy for those other three quadrants. Exactly. In quadrant I, everything is positive. That's our comfort zone. But the second an angle goes past 90 degrees, some of those functions flip and become negative. The real trick is just keeping track of which function is positive and where. And we're going to solve that right now. The solution is a super simple but incredibly effective mnemonic. You know, a memory trick that's helped students for generations. It's so easy to remember, and trust me, once you learn it, it's going to stick with you forever. And here it is. All students take calculus. That's it. That simple phrase is the key. The very first letter of each of those words tells you everything you need to know about the signs in each quadrant. It really is that straightforward. Look at how this breaks down. We start in quadrant I and go counterclockwise. The A stands for all, so everything's positive. Then in quadrant 2, the S means only sine is positive. Pop down to quadrant 3, and T tells us only tangent is positive. And finally, in quadrant 4, C means only cosine is positive. And here's the most important part. If a function isn't the one that's supposed to be positive in that quadrant, then it's negative. Simple as that. But here's the really cool part. This isn't just some random memory trick. There is solid mathematical logic behind why this works, and it all goes back to the basic definitions of trig functions on the unit circle. So let's do a super quick refresh of the basics. On the unit circle, for any angle, the x-coordinate of that point is its cosine, and the y-coordinate is its sine. And because tangent is just sine over cosine, it's simply y divided by x. This basic relationship is the entire reason our mnemonic works. Now check out how this table connects all the dots. Let's take quadrant 2 as an example. Your x-coordinate is negative, but your y-coordinate is positive. Well, since cosine is x, cosine is negative, and since sine is y, sine is positive. So what about tangent? It's a positive y divided by a negative x, which of course gives you a negative. See? Only sine is positive. This logic proves that all students take calculus isn't just a gimmick. It's built right into the geometry of the coordinate plane. Okay, so now we've got the what and we've got the why. So let's get to the most important part, the how. Let's actually apply this rule to a few examples, starting with the basic one and then working our way up. All right, let's go all the way back to that question from the beginning. We're not looking for the exact value just yet, just the sign. Is the cosine of 210 degrees positive or negative? Here's the simple three-step process. First, find the quadrant. Okay, 210 degrees. That's between 180 and 270, so it lands squarely in quadrant 3. Second, apply our rule. All students take. The T tells us that only tangent is positive here. So third, we make our conclusion. Since cosine is not tangent, it has to be negative. And that's it. Done. All right, time to level up a little bit. This time, we need the actual value. So what is the sine of 5 pi over 6? To figure this out, we're going to have to combine our new ASTC rule with what we already know about reference angles. Okay, let's break this down. First step, 5 pi over 6. That's just a little bit less than a full pi, which puts it in quadrant 2. Next, we find its reference angle, which is pi over 6. Now we know from our quadrant 1 basics that the sine of pi over 6 is 1/2. Now for the final, crucial step, we apply the sign. In quadrant 2, all students reminds us that sine is positive, so our final answer is positive 1/2. Okay, time for our final example. Let's put everything we've learned together and find the cosine of 7 pi over 4. First step, quadrant. 7 pi over 4 is almost a full 2 pi, so that puts it right in quadrant 4. Second step, reference angle. That's going to be pi over 4. Third, we find the value from quadrant I. The cosine of pi over 4 is the square root of 2 over 2. And finally, we apply the sign using our rule, all students take calculus. The C confirms that cosine is positive in quadrant 4, which means our final answer is positive root 2 over 2. See how all the pieces just lock right into place? Now that you've got the method down, let's look at the payoff. We'll cover one super common mistake to avoid, and then we'll see where this math has some very real and actually pretty cool real-world applications. So one of the most common questions I get is, okay, but what about the other three trig functions? Cosecant, secant, and cotangent. Does the rule still work for them? The answer is a big yes, and the logic is actually incredibly simple. Just remember this one thing. A function and its reciprocal partner will always have the same sign. Cosecant is just 1 over sine. So if sine is positive, cosecant has to be positive. That means the S, for students, in quadrant 2 also takes care of cosecant. And that same logic applies to cosine and secant and to tangent and cotangent. So where does this stuff actually get used? Well, one of the coolest applications is in physics and computer graphics. Every single time a character jumps in a video game or an engine simulates the path of a cannonball, the ASTC rule is running quietly in the background, doing all the hard work. Picture this. You throw a ball up and to the left. Its path goes into quadrant 2. Its horizontal velocity, which is governed by cosine, is negative because it's moving left. But its vertical velocity, governed by sine, is positive because it's still moving up. That is the ASTC rule in action. In quadrant 2, sine is positive, cosine is negative. It's the fundamental language that physics engines use to make motion look totally real. So there you have it. All students take calculus is so much more than just a little memory trick. It's a complete, logical system for navigating the entire 360 degrees of the unit circle. You now have the key to instantly know the sign of any trig function at any angle. The only question left is, what are you going to conquer next?